as the world seeks to reduce its dependence on fossil fuels and tackle climate change. Electric vehicles, EVs, have emerged as a promising alternative to traditional internal combustion engine vehicles. The zero exhaust emissions of electric vehicles make them look ecology-friendly at first glance. However, it is essential to understand that electric cars are not completely pollution-free. While they certainly contribute less to traditional forms of air pollution, they do generate a different kind of environmental impact known as invisible pollution. In this video, you will discover the hidden truth about how electric cars pollute. The invisible pollution. Battery production and disposal. The heart of an electric vehicle is its battery, which stores and supplies electrical energy to the electric motor. The production of these batteries involves mining and processing of raw materials such as lithium, cobalt and nickel, often involving practices that are harmful to the environment. These mining processes can lead to soil and water contamination, deforestation, and displacement of local communities. However, efforts are underway to improve mining practices and promote responsible sourcing. In addition, the battery manufacturing process consumes substantial amounts of energy and generates emissions. The production of lithium-ion batteries, for example, requires high energy inputs and, in some cases, the use of fossil fuels. As the industry works to reduce these emissions, transitioning to cleaner energy sources in battery production remains a priority. Battery disposal and recycling are also critical considerations. Electric cars' batteries have a limited lifespan, generally ranging from 8 to 15 years. Proper disposal and recycling processes are crucial to avoiding potential environmental and health risks. However, as battery technology continues to advance, there is an increasing focus on developing efficient recycling methods to minimize waste and maximize resource recovery. Life cycle assessment of electric cars. A comprehensive life cycle assessment, LCA, of electric vehicles is required to understand their overall environmental impact. LCAs assess the environmental burden associated with each stage of a product's life, from raw material extraction to manufacturing, use and disposal. When comparing electric cars to conventional vehicles, LCA studies generally show that the environmental benefits of electric cars outweigh their disadvantages. The comprehensive life cycle assessment analyses have consistently demonstrated that the operational phase of electric vehicles, which rely on electricity for propulsion, have significantly lower greenhouse gas emissions compared to gasoline-powered vehicles. However, these assessments must also consider the energy sources used to generate electricity, which brings us to the next aspect of invisible pollution. Electricity generation and grid emissions. The environmental impact of electric vehicles strongly depends on the sources of electricity used for charging. If the electricity is generated from coal or other fossil fuels, the emissions associated with charging EVs can be significant. However, as renewable energy sources, such as solar and wind power become more prevalent, the emissions associated with electric vehicles will decline. It is crucial to promote a clean energy transition, and increase the share of renewables in the grid to maximize the environmental benefits of electric cars. Also, time of day and charging location can affect grid emissions. Charging during off-peak hours or in areas with a high share of renewable energy can further reduce the indirect pollution associated with electric vehicles. Manufacturing phase. The manufacture of electric vehicles also contributes to their overall environmental impact. The production of electric vehicles involves energy-intensive processes, including the manufacture of light materials, assembly and transportation. Emissions generated during the manufacturing phase should be considered in the life cycle analysis to provide a holistic view of electric car pollution. Efforts are being made to reduce emissions at the manufacturing stage of electric vehicles. Manufacturers are embracing sustainable practices such as optimizing production processes, using renewable energy sources and implementing recycling and waste reduction strategies. Increasingly, Companies are also exploring the use of recycled materials and friends of ecology manufacturing techniques to minimize the environmental footprint of electric car production. Additionally, advances in battery technology are playing a significant role in reducing the pollution associated with the manufacturing phase. Improved battery energy density and longer lifespan result in fewer batteries needed per vehicle, leading to reduced manufacturing and resource consumption. While electric vehicles offer a promising solution to reducing greenhouse gas emissions and tackling climate change, it's crucial to consider the full life cycle of electric cars to understand the invisible pollution they generate. Battery production and disposal, life cycle assessments. Invisible pollution, electricity generation and grid emissions, as well as the manufacturing phase all contribute to the overall environmental impact of electric vehicles. Efforts are underway to address these concerns and mitigate the pollution associated with electric cars. This includes promoting responsible mining practices, developing efficient battery recycling methods, transitioning to cleaner energy sources for electricity generation, and implementing sustainable manufacturing practices. Governments, industry stakeholders and consumers must collaborate to drive these changes and ensure that the environmental benefits of electric vehicles are maximized while minimizing their negative impacts.